Hello, welcome back. It's just you and me, and we're going to write some code. We're going to write a game. So there's a video from a while back where I made a game framework and I wrote a little snake game in it. But I was definitely hoping to write a few more things. Today I got inspired. We're going to write a game that is a little bit like a game called JezzBall, or you might know it as K-Bounce, or there was something called, I think, Quacks or something, which was a bit similar before. But basically, balls bounce around and you need to draw lines to kind of chop up the space that they're bouncing in. It's going to be good. It's going to be good. All right, we're going to do it in Rust. So the game framework that I wrote is all here and ready, and I've set up enough of it that like I can draw this border. And I won't go into a lot of detail about how the game framework works, but the fundamental thing is that when a frame happens, we end up in this step function. And what this step function does at the moment is just draw some stuff on a canvas. It's also going to need to change things are going to need to move or whatever, and like change the state of the world. So basically the idea of the game is that there are these balls bouncing around, and then you control a line, or the ability to draw a line. You're able to draw lines that chop up the space that these balls are bouncing in. And if you chop up a space and there's no balls in it, that space is kind of claimed to be yours. It gets filled in. And you have to chop off enough bits of the space until you've done enough. So I don't know how far we'll get. Probably not the whole way to a working game. Like I was just thinking, like, how do you calculate how much space is used up? Like, you know, there's a lot of the tasks to do, but wouldn't it be nice if we could get to the end of this video with some balls bouncing around and us drawing some lines and things, maybe, I don't know, even filling in some space or something. We'll see. So where we're at is, like I said, we've got this game. All our code is Rust, but underneath it gets compiled to WASM. And then we're running. So the compiled uses WASM bindgen, and what else am I using here? The WASM pack here. WASM pack to do the building. As I say, watch the other video, and there's a blog post which hopefully, if I'm good, I'll link to, where it's all in text form as well, like how the code I wrote for this kind of fairly minimal game framework that just gives you a way to write Rust that draws on a canvas, essentially. And I'm running a Python server inside my public directory, which is where the compiled stuff gets copied into by this make thing. Just copies all the stuff into public. Running a Python HTTP server on that port. So then when I come to this page, I see my code running. All right, so that's that. So what we're going to do, I think what we'll start off with is controlling the line. I've got this kind of interesting idea of how I think I'd like to control the line. I'd like this to be a keyboard game. Maybe there should be some kind of mouse control that you can have as well. But right now I'm interested in the keyboard controls. I think it'd be quite a fun game to play with these keyboard controls, if I'm right. So what we're going to need is essentially the position of our kind of cursor type thing. It's going to be just the coordinates of our cursor. Should we have a point struct, or should we just... So I'm going to get rid of this direction thing because I don't think that quite makes sense. Should we have a... I think we should have a point struct, shouldn't we? So let's have a struct called point, which holds on to two numbers. Let's make them I32s, even though they're never going to be negative, because that's just, it's like the default number type, and I feel like having numbers that are compatible with each other is good. Maybe these should be U8s, because they're never going to... Just bear with me. I'm going to make them I32s, and we'll see if I've made a terrible mistake. So our position is going to be... I guess it's going to start. So I've made our grid be like 25 by 25, and the actual usable squares are 23 by 23. So that would mean, I guess, around about 11 would be the middle. Why have I done that? Why have I done it? And I've done it in odd numbers, so there ought to be a midpoint. I ought to be able to work that out. Will it be 1212? It might be 1212. We'll see. All right. So what's it moaning about? Oh, I didn't call it that. I called it point, didn't I? All right, like so, and that's got to be X, Y. We won't build a constructor for point now. We'll see if we get annoyed with it and want it later. All right, so our position starts off there, and what I would like to do is just draw like a dot at our position. So, all right, so let's talk a little bit about our context and stuff. So basically, what the step function does, which gets called every frame, and we can adjust the frame rate here if we want to. What this does is gets hold of a context, which is basically how you draw onto an HTML canvas. And then what you do is you set the fill style, and then you call things like fill rect, which draws rectangles, or we can draw other shapes as well. And what we're doing for the border is we're setting the color to this color, and then we're doing draw square, which is a little function I wrote. It takes in a context. Where is it down here? Takes in a context and an XY position and scales that up to basically 6 times. So it's a 25 by 25 grid, and the canvas resolution is, I've made it 150 by 150. So let me just talk about that. So basically in our game framework, we make a canvas and we say its width and height in the HTML here. Actually, I've made it 151, I forgot. And so once that means that's the number of pixels in that canvas. So if I look back at the thing, each of these squares is like 5 pixels wide, and then there's 1 pixel in between them. So 6 pixels make a square on this board. We're going to draw some like balls and things that are not going to be just like kind of fake pixels like that. So it will make sense. We do not have a direction at the moment, so we can't set the direction when the key gets pressed. But anyway, what draw square does is just scale it up, draws a dot, like a square in that position that looks a bit like a pixel, but with one pixel missing from it, because I think that's just kind of a sort of attractive look. By the way, this can I show you that? Yeah, this thing scales that, like I've done that with CSS, so it just like fits on the screen, whatever. So sorry for the white blast. All right, too much faffing around. Let's draw a square at the position of the player. So the player is going to sit at, it's going to have like a position. You're going to use the arrow keys to move it around. And my idea was, whenever you move vertically, you're ready to draw a horizontal line. And whenever you move horizontally, you're ready to draw a vertical line. I think that's going to feel natural and fun, or it might feel awful. So I guess we'll find out. So what we want to do is choose a color for this dot, which is like directly at the center. At some point, by the way, this step is, all the code in here is going to be part of probably like a view function. But right now, all step does is view, so I guess we don't need to do that yet. All right, so what color? So I said the active line color should be this. That's if I was thinking that would be if a line is drawing itself, it should be this. So I guess at the point where you're not actually doing anything, I think just pure white, just the brightest possible dot to say this is where you are would be nice. So if we compile, it's annoyed because direction is no longer being used. Let's just get rid of that file completely and get rid of it from our code. Hopefully no more warnings. Yep. Okay, meanwhile we've built that code so we can run it. And then, hey, it worked. There's a dot showing where we are at the center of the screen. I guess let's use the arrow keys to move it around, shall we? Why not? All right, so how fast should you be able to move? I think probably once a frame. So what we should do is remember what button you pressed, and then at the end of the frame, move you in that direction. I think that's the thing to do. So maybe we want that direction thing back. So I think this is going to be an option. Like most of the time, like this is like your next move, the direction of your next move. So in fact, I think we should just call it next. Let's call it next move. And we'll make it a point, an option of a point. So most of the time it's empty, but if you've pressed a movement direction, then it becomes non-empty. So next move starts out none. And when you press a direction, for example, when you press left, then next move, self dot next move is going to be a point that will move you. There's going to be like a relative point, but I'm going to reuse point for that. I think that will probably be okay. So it's going to say move you to the left by 1. It should be your sum. Right, and then up, right, and down do the same thing. Which these are the key codes, by the way, like what it says here. When a key event comes in, you get this key code, which is a number. I happen to know that it's up, down, right, and left because I wrote those down earlier. So moving up is going to be moving y by -1. Whoops. And moving right is moving x by 1, and moving down is increasing y by 1. So that's like how much we want to move next time step. So this means already we've got like some, let's call it physics. So let's say, is physics the right word? No, let's say that it is. And then the next thing will be view, and then we'll stop. So we're going to have a function called physics step. Mute. And we're going to have a function called view, which hopefully won't take a mutable reference to self. It'll just take a reference to self. And then we'll know for sure that the view doesn't like break out of its role and start modifying things. It seems like the compiler's happy with that. All right, so the first physics step is when you press the button, let's move in that direction. So if there's some next move, what's it called, next move? If there was some next move, then modify our position by that amount, which we're going to have to implement a add a sign for points. We can do that. So I'm just making the plus equals operator work by saying that should be input add a sign for point. By saying point has a plus equals operator, and here's what it does. What it does is kind of what you'd expect. Right. Now, we should be taking a reference to the next move here. I guess we can take it. Let's take it. Because we want it to end up as none after we've done this. So next move is an option. We want to take the thing out of the option. If it's in there, if it was in there, we want to do something. But either way, we want next move to end up being none. So I think that's quite nice. All right, so I think we'll see that happening. Now I can use the arrow keys to move around, right? Refresh. Looks like it, although it's a bit unresponsive. Oh, I think our frame rate's quite low. Let's make our frame rate higher. So what we did here, this was for a snake game, which was moving like once every frame. That was the kind of thought behind that. So generally, so all I'm doing here is setting like what's the next time I want you to run an update for me. So we could be running at 60 frames a second. We could be running at, say, I mean, 30 frames a second. What's going to feel good? Like, I don't want you to be able to move so fast. Or do I not mind? Maybe if you just hammer the... No. I want you to be able to hold the button and it move at a certain speed. All right, so we're already... I'm not sure what we've got is going to work. Because we're just doing key down here. Right, so but anyway, we'll think about that in a second. So I think I want, let's say 30 frames a second. So how many milliseconds is that per frame? So that would be 1 second is 1,000 milliseconds, and if we have 30 of them, it would be 33-ish milliseconds. So let's say like 30 milliseconds. Like so. Is that going to be okay? It looks okay. So now we'll find out whether that maths was at all right. All right. So yeah. All right. So it feels more responsive now. I can press it quite quickly and it does what I want. So that's good. We may find that 30 was too many. It's fairly fast, but not too bad. But that's using the key repeat speed on my keyboard. So 30 frames a second might be too fast. But let's address the fact that we want to actually remember that the key is down. So how are we going to do this? In my Snake game, I did some like sophisticated stuff about remembering all the buttons you pressed. I think all we want here is we want the last button that went down should be the one that wins. And when you release a key, it should, like if you're holding 2 keys down and you release one of them, it should go back to the other one. So I guess we do need some kind of thing that remembers what keys are pressed. So that is going to be what we had before. I think we're going to need similar. It's going to need to be some kind of stack of I mean, it'll be key codes, I guess. Let's just... What are these key codes? They're U32s. So let's just have a stack of U32s. U32s. And then we'll do something like, if one of these keys gets pressed, then we'll call the down function. Which takes in let's call this key codes. Takes in a key code. And basically it removes, basically what it does is if you press the key, it puts it to the top of the stack to say the kind of winning key at the moment is this one. So what we need to do, therefore, is remove it if it already exists. Which I think will just be this. Does remove take an index or a value? No, it takes an index. That's no good. Not that. There's a retain. I think we need a retain, and then we just say retain anything in key codes that is not this new key. And then we'll push. I think this would be good, yeah. Just push it onto the top, and we'll say that the last thing in key codes is the kind of current thing. Something like that. And then when you release a key, we need to also remove it. I think we'll just remove it. I think that'll do it. So let's hold on to the pressed keys. Let's get rid of this next move. I think that was a bit of a blind alley. So keys pressed is that. I guess let's have a new function on that, because it's going to get messy to try and initialize that. So the new function makes a new keys pressed, which will just start with an empty list of keys that you pressed. And then when a key is pressed, then, I mean, I guess we only want the keys we're interested in. We could just do all of them. What's best here? For now, let's see how we go with just all of them. Just pass in the key code, which is here. Now, we also need some kind of on key up, which I think we haven't implemented. So we've got to go back to the code where the kind of game framework code, and do something pretty similar to this. I guess we can rename this set keyboard listeners with an S. And these should all be key up. And is that good enough? That might be good enough. Now we just need a function called onKeyUp to exist. And it's going to be nice and simple, because it's going to just call up. Wouldn't it be great if we had some tests for this keys pressed thing? Let's write some. So we're going to need a test that, well, I guess we haven't yet written any code to ask what's the current pressed key. So I guess this test this test is already pushing us to make things make sense. So let's just say no keys pressed means no current key. So if we make a keys pressed, and then we ask it, what is your current, let's just call it current, shall we? What's the current key? It should return none. All right. So I guess we need a current function. Let's write one. At some point, we're going to want this in a separate file, I guess. So we'll have a thing called current, which returns a key code, I guess. We might want to make that we might want to, at some point we're going to have to process this to decide what the meaning of keys. So maybe instead of returning a key code from here, we should return some kind of known input. Or maybe let's just do it directly with key codes and see how we feel about it. We don't want to over-engineer things, do we? All right, so that's just going to be self.keycodes.last, I think, because actually it should be an option of i32, because we're expecting it to be none. And last already returns an option. Oh, but it returns an option of reference to thing. Can we as deref? Is that a thing? Maybe option.copied is what I mean. Thank you for that helpful error message, Rust. Yeah, that worked. Great. Lovely. So yeah, we were returning an option of a reference to U32. I think it's just simpler to return an option of U32. There's no point in using a reference to something that's already U32 in size, so it was just making our lives more complicated. Okay, what are you moaning about? Oh yeah, we don't have next move anymore, so that's yeah, right, we'll get to that. Okay, so where were we? We were tracking what key got pressed and we were writing a test for it. All right, so another test. When you press a key, it's the current key. When you press... I wish I'd written these tests before I wrote the code. It is the current key. So we're going to say I pressed, say, 37, 38. Then we should be asserting that the current one, which will unwrap, meaning we assume it's not none. Now this should be mute, I guess. Yeah. Yeah. When you press the key number 38, let's write something here. When we press 38, then it is the current key. Let's say when we press 38 down, because that's what we're doing. And now I've deliberately inserted an error here, so we can see a failing test. Oops, I forgot to set this going before we started. Right, so what else? We're going to need another test of when you release the key, it's no longer current. So let's try that. When you release a key, it is no longer current. So if we, I guess let's say given 38 was pressed down, when we release it, so we do an up, then there is no current key anymore. So this will be back to asserting that it's none. Now there's a lot more cases. You can see why I want to write tests for this, because there's a lot more cases, aren't there, that we really want to cover. Now, it's not going to let me run my tests because I've got errors. So let us get rid of everything from physics for a second. We don't need it yet. And find out where our errors are. All right, so... the problem here, I guess, is that game is being moved. Yeah, so we need a clone of game to be able to use it in two places, basically. So look away if you don't know what I'm going on about here. The video about the game framework talks about how all this works, but basically if we're using game down here, you're inside a move closure like this. We can't have already moved it into this closure up here. All right, have I fixed it? Yes, and look, we've got the error that we were expecting, which is that the current key should be 38, not 37, and you'll notice our last test that we wrote is passing already. It'd be kind of nice to see it fail, so I guess we can make it fail by breaking it like that. Yeah, it fails. Okay, so good. Passing tests. And a warning. What's the warning? Oh, well, the current method's only used in tests so far, but we'll fix that. All right, so just a couple more test cases for this keys pressed thing. So first of all, if you press another key, then that should become current. The latest key is current. And let's say given 38 was pressed, when we press 39, then 39 is current. Where's our assertion about things? So, like so. All right. Does that pass? It doesn't. Why not? Oh, because I did an up instead of a down. Okay, good. I thought the real code was broken. I think it's still just tests being broken. Great. That works. Still a warning. Yeah, we've got that. Okay, so now the other thing, so basically you can jump the queue, but what I want to check is that you still jump the queue even if you were already in the queue. So Maybe this can never happen in real life, but I think it's worth covering this case. Repressing jumps to front of queue. So let's say given 38, 39 and 40 were pressed in that order. So 40 should be current. So let's just do a sanity. Sanity 40 is current. When we press 39 again, then 39 becomes current. All right. We still haven't tested that, like, all right, that passes 2. We still haven't tested that if you release the key, the one previous in the one in the queue becomes current, which is actually kind of the whole point of this thing. So releasing a key makes previous keys current. So you may think that this is a bit of a rabbit hole, but like games are all about feel, and if you're pressing 2 keys and you release one, and then the one you were holding as well no longer works, it feels bad to me. So I think this is worth the pain. All right, so I said sanity 40 is current, but I didn't check. I just wrote the comment. That's not good enough. Do the check, Andy. All right, so there we go. All right, so when we release, let's release 40. When we release 40, then 39 becomes current. Yeah, that's right. I'm a bit uncomfortable with 39 always being the right answer, so let's just go with 37. Like so. See it fail, and then we'll change the answer to 37. Yeah. All right. And the comment. All right. So is that a good enough test? I mean, let's just do one big one. Releasing many keys reveals latest remaining. So let's imagine we pressed, given lots of keys were pressed, including maybe some repeats. So let's do 31, 32, 30, 33, 34, no, not in just numerical order. So let's do a 39 and then a 38 and then a 39 and then 31, 32. When we release several, so let's release 32, 31 and 38, let's say. Then the latest remaining is current, which should be 39. Is 39 the correct answer again? I don't like that. I'm just going to make it 30 just to satisfy my sense of not... We could have some weird corner case where 39 always comes out and the test would pass. Okay. All right. So I think we've done enough testing that my key thing works the way I think it does. You may not even... Hopefully you figured out what I meant by that. I didn't explain it very well. That hopefully the test helped explain what it's for. But the point is, I think it's the way that feels natural when you're using a keyboard-controlled game. However, we've actually removed any logic, any physics that happens based on what key is pressed. So let's do some physics now. So we're going to match the keys pressed dot current, and that has got, like, it could be none, in which case we do nothing, or it could be like one of the keys that we were dealing with earlier. Have I now deleted the code that I have? So it was 37. No, I actually can't remember, but we've got a copy of this. No, in fact, I think we need to do a git diff to see. I could just, obviously I can check out the original code for the framework which had this in, but yeah, okay, so 37 is left, fine. Where were we? Yeah, 37 is left, so what we're going to do is, well, at some point we have to check whether we're off the side of the screen. So let's not do that yet, because I'm not 100% sure exactly how we want to do that. I'll tell you what, we could just do this. And then it's actually simpler than that, the adding points. So we don't need the adding points code. Let's get rid of it. We might want it later. So I'll just comment it for now. You don't want to have to watch me do it again. So 37 was left, 38 was up. So that means we're changing y by -1. 39 was right. So moving x over by 1, and 40 was down, which moves y, increases y by 1. That should be plus. And then we've got to handle the none case where we do nothing. What are you moaning about? Oh, there's other sums as well. So I guess if you're pressing other keys, we'll do nothing as well. Right. Okay, we imported thing that we're not using. Check our tests pass, and then build the code for the web and run it. And hey, we're allowed to move, but is it too fast? It's a little bit too fast, maybe. Oh, I could get used to it. I think just a touch slower, and then if we feel once we play the game, we're going to find that it's going to need a lot of tuning before it's fun, and we won't get to that in this video. But yeah, all right. So we can move our dots, but we can go off the edge. And I don't know what bad things happen when you go off the edge, but theoretically bad things happen. So let us. Okay, all right. So the other thing is I probably need to test the thing that I just implemented, right? So yeah, hold down right and then press that, tap up, and look, you can see it continues moving left, which I feel like is the right answer. Good. All right. So the key pressing thing appears to be about what I was hoping for. So what did I just say? Oh yeah, we've got to stop it going off the edge. All right. So we can do it here. I don't think we want to. Like, if you're pressing right, if you're pressing right and up, but right is winning because it's the last one you press, I don't think we want to start moving up the wall. Or at least I can't be bothered with that. So we'll see how it feels. So this will be if self pos x is greater than 1. So is this okay? This seems like it might be okay. It's like we're saying self.pos.y a lot of times, which isn't my favorite thing. Less than. What did I say the size of it was? 25. So I think it needs to be 24. Let's see. This will be testing by trying it out in production. I haven't written any unit tests for this stuff, and I don't think I'm particularly planning to. If I was going to release this game commercially, I would. Oh, hold on. You probably need to not only compile the code, but also refresh the page. Yeah, there we go. Oh, so it's stopping one too far along. Presumably also in that place, yeah. All right, so that needs to be 23 then, I guess, because 24 is the last position it's allowed to be in. So we can't increase it. Oh, what? Oh, refresh again, please. There we go. Okay. And now, if I forget to refresh, I'd like you to shout at the screen, please. By the way, The name of this game I chose, JezzPuck. If you've been watching any of my videos, you'll know that I have this great friend called Jez. I found out this week he's really into hockey. Maybe I should have known that already. The game I'm copying was called JezzBall with a double Z. Nothing to do with Jez, as far as I know. But yeah, my friend Jez is into hockey. Let's call it JezzPuck. The puck's like a ball. That's the idea. Jez is like Jez. Okay, so I feel like a commit is in order. Speaking of Jez, he would be shouting at the screen, where's the commit? Let's do a commit. So let's just say allow moving a dot around the screen with arrows. Cool. Okay, what's next? I want to draw a cool looking line that extends out of our dot and tells you whether we are drawing a horizontal or a vertical line. I might want like a really ghostly, also vertical line, because it kind of feels like a target, like you're controlling a target, which is sort of nice. Is that because I played too many gun games? I don't know. Anyway, so let us draw not just a square, but also a line, which is either horizontal or vertical, and maybe we'll consider the other as well. That means we need to know, are we currently horizontal or vertical? So what we're going to call that, I guess it'll be like something like orientation. And we'll make ourselves an enum called orientation, which is just horizontal or vertical. I'm going to abbreviate them because I just feel like they're going to get too annoying to type if I don't. Although the word orientation is really long as well. We're going to live with it. Okay, so we start off with an orientation of horizontal, I think. And when, okay, so we're already at a point where would have been nice to have a little bit more abstraction around this key pressing stuff, because I need to do something else now. So I guess if you move horizontally, even if you can't move horizontally, we still want to, if you press the up arrow, we still want to go into horizontal mode, I reckon. It would feel weird not to. So actually, let's do it here, and let's do maybe this should only happen if the keys pressed are ones we recognize. So let's find out what you pressed and put it into some kind of nice enum. So we can do if let's direction key equals, so we're gonna use the code, and we're gonna create a direction key from code. And that from code is going to return either some or none. And then once we've got a direction key, we're going to do something useful with it. So now we'll be matching on direction key. And then this logic about which keys are valid is going to end up being inside this from code thing. So let's make ourselves a struct called direction key and go from there. Maybe this should all be in separate files. So, I mean, the direction keys are just, what order are they in? Let's do them in the same order. Left, up, right, down. Left, up, right, down. That should be an enum, obviously. And then we're going to make a function called, what did I call it, from code, which takes in a key code, which was a U32, I think, and returns an option of self because it's either going to succeed or not. And we're going to do a match exactly like this one. Let's have it. Except these ifs. Oh no. Okay, so let's keep this match down there as well because we're going to use some of it in a minute. Where was it? Where was it? There. It must be in the on. No, it's in the physics world. Physics step. Oh, I've already. Oh, it was confusing me. I had left it there. I thought I'd removed it. Okay, I haven't pasted it in here. How weird. I must have. Okay, sorry. I don't know what happened to my brain. So if we've got. Okay, key code was already an option. Let's keep that as an option of U32 because that's what we're getting back from the current function. So we're going to match on key code. Obviously, if it's a none, then obviously we return none. Or also, if it's just a key code we don't recognize, we return none. What is going on? I haven't got enough curly brackets. Okay, so we need to return, in this case, some left. This feels a bit nicer. We can see what the key codes mean very directly here, and we don't have to kind of memorize anything. There's right next, and then now if we get this wrong, of course, it's going to really confuse us. So we better check it in a minute. What is that down? Yeah. Obviously, they need commas at the end, like so. Now, what have we broken? So much stuff. So we get back a direction key. So now the match arms are going to be just left, right, up and down. And we're going to want to do the ifs here. Oh, and they're not nicely lined up anymore, which is a real pity. If only all the direction words... Oh, that should be greater than 1. If only all the direction words had the same number of letters in them. So... we're going to do one match on just, like, if you're pressing the key and you're allowed to move in that direction and do the thing. We're going to do a second match. I don't know, like, maybe this will generate, like, really efficient machine language. Or maybe not, but we're not, that's not why we're writing it. What's your problem? Left, right, up, down. Yeah, the point is, if you weren't, then we should just do nothing. So if you were near the edge, do nothing, essentially. We still need that in. And I've deleted the code that actually does the thing. So, were you shouting at me not to do that? Minus equals 1, self.pos.x. Plus equals 1, self.pos.y plus equals 1. All right. So now we've got a match which says if you're pressing the right key and you're not already by the edge, modify your position. Now we're going to do another match, like I was saying, on the direction key. And there's only 2 cases now. You've either pressed vertically, not moved necessarily, but you've either pressed vertically or you've pressed horizontally. So we're going to do an or. So left or right and up or down. And based on if you press left or right, then we're going to change our orientation to be press left or right, so orientation becomes vertical. So this is a little potentially surprising, but when you press left, I want it to be a vertical line there. I think it will feel right. This is all based on my feelings about what's going to make a nice feeling game with no evidence. No, we did not want to commit. That was me not thinking before I pressed. What we want to do is build the code, test it, and see if we can still move around. Yeah, we can move around, and I think the speed of the line feels not too bad now. So we've set the orientation, but we're not rendering it. So we better render it, otherwise what was the point? So, yeah. Should we be writing tests? Probably, but we're not going to. Okay, so the color that I thought might be right for the ghost line was something like that. So once we've drawn our central square, we're now going to draw a ghost line. By ghost line, I just mean like it shows where you will draw a line when you press space, but we haven't implemented that yet. So we're going to loop from 0. Hang on, I guess let's not call it X because oh wait, hang on, we need to figure out. Okay, so the kind of I min. So basically, we need to loop from like 0 to something, not draw at the point where our. I mean, what we could do is just draw, like, just not worry too much about drawing things twice. Draw the ghost first, ghost line first, and then actual position dot last, and then we can draw over the top of our ghost line. So now we're just gonna need to know, like, we're gonna loop from 0 to 24, I think. Well, less than 25, from 1 to less than 25. We're going to draw a dot at every place, a square rather. And it's just a matter of whether we're going horizontally or vertically. So it's going to be something like let x equal, oh, actually let x comma y equal, if the orientation is vertical, so we can ask for the orientation, match on it, and if it's horizontal, x is going to be, so this is really inefficient because we're matching on the orientation every time, every square. So let's not do it. Let's do it nicer. Let x min x max y min y max equal. All right, now we match it on the orientation. No, it shouldn't be x min and x max. It should be x and x inc, y and y inc. I think that's going to be the nicest way to do it. And there's some syntax problems here, which are meaning it's not formatting for me, which is making me nervous. All right, so if we're in horizontal mode, the x is going to start at 1, and it's going to go all the way up to, no, it's going to increase by 1 every time. Y is going to start at the y position, and it's never going to change. Whereas if it's a vertical line we're drawing, x is going to start at the x position of ourselves and never change, and y is going to start at 1 and increase by 1 every time. So now we loop from 1 up to 25, and we draw a square at xy, which we just created, and then we add the increment to x. I think this is going to work. X inc and y gets white ink added to it, and one of those is going to be 0, so maybe this is wasteful, but surely not as wasteful as doing this if every time around the loop. And who cares about waste anyway? This should obviously be a 4. I don't know what I'm writing there. And X and Y need to be mute for this to work. And we don't actually use I. And that's not how you write for loops in Rust. Okay, we've got there. I think this might work. Let's try it. Why aren't there any tests, Andy? Then you would know whether it works. Hey, look. A horizontal line that goes 1 too far. Or a vertical line that goes 1 too far. Of course, it goes 1 too far because we should be doing this 23 times. So let's just count from 0 to 23. Yeah, look. Oh, look. It's a horrible color that I chose for the ghost line, isn't it? We don't like it at all. I think it should just be kind of a light grey, but slightly bluish light grey maybe. So the ghost line should be, well, when I say light, I mean dark. So the ghost line should be something like CC. Slightly blue, dark grey line. No, that's not a dark, that's light, because I seem to have got light and dark confused in my mind. It's going to be 4, 4, 4, 4, 8, 8 maybe. Okay, that's a bit too bluish and a bit too light maybe. No, maybe not. Maybe just a bit too bluish. Still a bit too bluish. It just wants to be the smallest hint of blue. Maybe also still too bright. Okay, now it looks very grey. Too grey. Bit bluer. Alright, we'll stop faffing with that. Okay, so far it's feeling good to me that when you move horizontally, it becomes a vertical line. When you move vertically, it becomes a horizontal line. It'll maybe take a bit of getting used to, but hopefully it'll be okay. All right, so the next thing we need to do is be able to draw lines based on what we pressed. So I guess there's going to be two modes here. There's going to be either I'm in line drawing mode, either a line is currently in progress being drawn, in which case I can't draw another one right now. I guess that's how it works. And it's potentially vulnerable to being hit by balls, which is what can go wrong. Okay, so I guess it's like currently drawing line. So let's just call it line in progress, which I think is going to be an option because sometimes it's not in progress, sometimes it is. And then I guess there's going to be a thing called line in progress, which is another struct. And that's going to be essentially, it's going to be drawing outwards from where you started from. It's going to start kind of dots are going to run outwards from where you were towards the edge of the board. So how are we going to represent that? I guess it's going to be maybe just a starting point, and I think what I'm going to do is a positive distance and a negative distance, even though it feels like you only need one distance. But that's because at some point it's gonna hit. And once it hits, it's no longer vulnerable. That line, the lines basically get bashed by a ball if they're still in the middle of drawing. If they finish drawing, they become solid blocks. So I think we're going to need a start, which is going to be a point, and a pos dist positive distance, which I think it will default to U32, and negative distance, which is going to, sorry, I32, and these are going to be options, because once we hit the edge, they're going to kind of disappear, and they'll turn into something else, but we'll deal with that later. So there's only ever one line in progress, so I think this is fine. There's only one of these, so line in progress here is going to have to be none. And it's complaining that this is never used because we're not doing it. So I guess the first thing to do is to say, when you press space, because that's the thing I'm planning, then start a line off in progress. All right, so let's listen for key downs. And I guess we can just do, in the down method here, let's just print out the key code. So the trick for writing, or one trick, there's a bit of a complicated way of writing to the console in this thing. I'm confidently saying it, but is it actually going to work here? So WebSys provides a console. It has this method, these methods like log1, and they take a JS value which you can create by making a string reference and calling .into on it. So this is how I've figured out how to do it. So key code. It would be nice to just debug, use the debug macro and have it just work. Maybe someone could add that to JSSys or WASM pack or something so that it just worked. All right, so we need to look at the console to see. Oh no, I only wrote this down so that I would find the key code for space, which is 32. That's why I did all of that faffing. Should have explained myself. So the key code for space is 32. That means we don't need console imported anymore. So there's not only direction keys now, we also want to know where is it? Who calls from code? That's where we want to jump to. These were in separate files, might be easier. Soon we're going to get to that point. So we want to say if let. No, I guess it's just if key code equals 32. Let's not be too precious about it right now. Like in theory, you could do something similar to this, where you do like space key from code, or like it wouldn't even be space key. It would be like do something key. Space is code 32. So if you press space, then we are going to we're going to basically make a line be in progress. So we're only going to do this if line is not already in progress. So if line in progress is none, then we're going to make the line in progress be something. I'll tell you what, the line in progress needs to have an orientation on it, doesn't it? Because it needs to know whether it's, well, it needs to have an orientation, obviously. So, fortunately, we've already got an orientation struct, so we can just reuse it. I think it'll be fine. So, where was I? Yeah. So, it's going to be a line in progress. The start point is going to be our pos. The orientation is going to be our orientation. And the positive distance so far is going to be 0. Negative distance is going to be 0. I think could be 1. See how it feels. I know I'm saying that a lot. Should be an and there. Yeah. Now. Okay, they should be. These lines exist. Oh yeah, I think starting out at 0 is a good idea because there might be 0 steps to do before you finished. So yeah. Oh, it wasn't called key code. Oh, we didn't put it into a variable. Let's put it into a variable. if I can do that. So we made it from key code. Key code should be copy if it's not. Now, are we inside? We're not inside the. Okay, so if. All right, so I guess we need to say. If there is a key code and the key code is 32 and there's no line in progress, there should be a single equals. Oh, how are we not writing Rust 2024? We definitely should be. Let's change our addition on the fly. See whether that breaks everything. Yeah, I wonder why. Oh, maybe when I wrote the framework, Rust 2024 wasn't out yet, or maybe I just accidentally had the wrong edition, or what? Because I copied the framework in here to do it. Okay. So we should be copying points and orientation. Well, orientation should be copied. But let's just make both pods and orientation copy. Like, they're just not expensive to copy. So, they should probably be. Shall we derive debug as well? Why not? Clone, copy, debug. Let's have that for orientation as well. Okay, so that compiles, still runs, nothing happens when we press space. So we better have something happen when you press space. So basically, every time around the physics, if there's a line in progress, we should do something. So maybe we should do key presses as a separate function. What do you think? Physics. And it's key press physics step. If I somehow I've gone with the convention of appending. I mean, really, there should be a struct called physics that has methods that does these things. Self dot key press physics step and self dot line physics step. Have I done things other than key presses in here? I have. No. It's not really. It's like it's not key presses. It's like keys that are currently pressed. So maybe this should just be called keys. Oops. Keys. All right, so we're going to make a line physics step. Does stuff with the line, if there is one. So if there's a line, what's it called? Line in progress. If line in progress, if let some line in progress equals self dot line in progress, then we do all the stuff we do in this function. We should probably be getting that out as a reference. Possibly a mutable reference. Definitely a mutable reference. So yeah, any line in progress, we need to add one to both of its thingamabobs. So line in progress has a start and orientation. So positive distance needs to have one added to it. And then we need to check whether it hit the edge, which we'll do in a second. Negative distance needs one taken away from it. We won't check the edge yet, we'll just draw these things. Oh, they're both... we need to do another if. This is a bit painful, isn't it? We could do some kind of... I just prefer if-let in almost every case. So if we've got a positive distance, then add 1 to it. It's more verbose than map, I think, but we should be dereferencing it and adding 1 to it. There we go. And let's do the same thing for negative distance. Except taking away 1. Nearly missed that. And now we better render this line so we can see whether this is working. So we've done the ghost line, but if there's a actual line, maybe we don't draw the ghost line. I think we don't draw the ghost line. No, we might still. Let's try it with and see what happens. So after ghost line, we're going to draw the active line on top. And I picked a color for that, which is probably a terrible color too. But we'll try it. So this is going to do basically the same kind of thing as... No, it's not. It's going to start from the middle and work outwards. I think that would be the sensible thing to do. So let's just start off with just an if. First of all, we find out if there is a line. If there's some in progress line, then we're going to start from its position. And then we're going to, it depends on whether we're going horizontally or vertically. So let's just start with separating those out and see what we can. So if it's a horizontal line, we'll do something, otherwise we'll do something else. Hopefully we'll be able to make this better in a minute. We're going to draw a square. We're going to loop. This is a horizontal line, so we're going to loop over with X, starting from the pos, like the in progress lines position, X position, and then continuing to that position. So let's just have some variables for this. So start will be this, end will be start plus in progress line dot Why aren't you completing this for me? Oh, because it doesn't know what in progress line is. What did I call it? Line in progress. All right. So let's just spell it right. So line in progress should have a positive distance. And then we go from start to end. And we draw a square using context and X and the Y thing. So I guess, yeah, it's a similar pattern to what we had before, but not quite the same. So let's, again, I said I would do it simply, didn't I? So let's make it simple. Pause. dot y. Now, what's it complaining about? Oh, it should be called start, not pods. I just made up, dare I say, hallucinated a whole load of stuff there. Alright, and actually we need to, this only works if posdist is, actually, if there is some more work to do here. So if posdist exists, then we draw this thing. And we don't need to use, we use the posdist that we extracted out. And I mean, we can just say so we can use the matches thing because it's saying that we don't have partial eq, so we can't compare these things. So matches takes in an expression and then a thing to match, so that's what we've done. Fine. Now let's match against a reference. So if it's horizontal, do that. Now if it's vertical, it's going to look similar but different. Maybe we can abstract. It's vertical. So we're only drawing the positive line so far, but that's fine. We'll see that. So start and end are going to be based on y, and x is just going to be the start x, like so. And we've got some kind of syntax problem. Maybe we're missing a curly. That looks happier. Let's build it. I think something should happen now. Yeah, look at that. When you press space, the active line shoots out from your dot. Cool, cool. I guess we should start one. We shouldn't draw the one that's actually on your square. Where is the view? So we should start from one more. So start should be that plus one. So maybe now let's think a little bit about, can we turn this into a single piece of code before we so start is easy, right? That's just, we're just going to match on the orientation. And it's going to be based on either, if this is a horizontal line, then the start position is the x position of our line, start, and similarly if it's vertical line, it's going to be the y position of our line start. So now we've got start, and that's suitable, and end is actually even easier because end is just that. We're still only doing positives at the moment, but only if there is a positive distance, of course. So we've got to do that if let again. Then we're going to do some kind of loop like this. But let's just comment this stuff out for a second. But we need to work out, so let's call this thing I. And then we're just going to, I think we'll have another match here. And just do two different things. Maybe we can improve this again, but anyway. We can ask for, give me x and y. If this is a horizontal line, then x is going to be I, and Y is going to be the start, the Y position of the start is not going to change. And similarly, if it's a vertical line, it's going to be the start position X and then I. So now we draw a square at X, Y. Hopefully that will still work. And it works for horizontal world, works for vertical world. All right, so that's working. It's working. And it no longer draws on top of our dot, which is good. Do we like the ghost being there? We'll see. It seems okay. Is that the right speed for it to be moving? We'll see about that too. All right, so we need to draw the negative line too. So I guess it's going to look similar to this. If there's a negative distance still. The negative distance, I guess it's going to be minus. I think the negative distance is going to increase by 1, right? We didn't minus equal it, did we? Have we not changed it at all yet? Oh, look, no, it did minus it. Fine. That means that when we use it, since it's negative already, we're just going to add it on and it will actually be negative. But that means we need to go from end to start, I reckon. And that's even worse because hang on. No, we are still drawing the first dot. I was talking rubbish. So start actually needs to be oh no, we need to go from start plus 1 to end. And now we need to go from end minus 1 to start, I think. We'll see if that works. And we'll draw the thingamabobs. Is that stuff still the same? It's the same. Let's try that. Could be total rubbish. No, it seems to be drawing the two lines, but one comes quicker than the other. That doesn't seem right at all. I almost feel like it might be end minus 2 to start minus 1. Would that be just strange? Yeah, that was strange. So why did it look slow when I did it? It looked like it came out of the left quicker than the right, didn't it? So the negative came quicker than the positive. Yeah, same on the vertical axis. So actually the negative's correct and the positive is somehow wrong. So we have a positive distance. And the end is going to start off. So pos_dist, when you first go, pos_dist is going to be 0. And neg_dist is going to be 0. All right, so it shows up like one time step too early. The negative shows up on the same time step you press the button. But maybe that's good. But anyway, if you've moved 0, you should not be drawing anything. So I think maybe it should be from end to start, minus 1. Let's try that. I'm just guessing, and this is why I normally write tests to make me less terrible. Maybe just from end to start? That would be really strange. It's got to be n plus 1 to start, surely. Yeah, don't include start, that seems right. But also don't include end. That's better. Okay, fine. Okay, so yeah, how's that? How's the speed of that? We're gonna see how it plays. All right, so that was just making the line kind of extend out of our dot, but now we need it to stop when it gets to the end. So this is the drawing code, so we're not in the right place. So when we get the physics of actually changing the line, we need to check whether we've hit the edge, basically. So I guess we do it in here, and we say if the line is oriented horizontally. What's the west bound? Actually, tell you what, it doesn't matter. It doesn't matter whether it's horizontal or vertical, because the playing area is square. So we can just say if the start of the line plus pos dist is bigger than 24, I reckon, then pos dist is none. We're going to do something else as well to make actually the to make it some other line appear instead. But anyway, so this should be the start. Oh, we need to know whether it's X or Y here. So we need to say something like match on the orientation, like this. If it's vertical, the start will be the X position. Start X. If it's vertical, start Y. Now this should be just this new start that we made. What is start? Start is 932, pos dist is a reference to 932. So if you've hit the edge, then actually your line in progress, your pos dist, as in like you no longer are moving in the positive direction. And similarly, actually we can do this, create this start here. And then just have another if similar to that in the negative world. If we add the negative distance to start and the answer is less than 1, then the negative line stops moving. So now if we try it out, the line should extend out and then disappear when it hits the edge. And if we get close to one edge, okay, we also need to check if they're both gone, then actually the line in progress becomes none. This is not allowed. So instead of that, we're going to have to like change something. So we're going to like need to return some kind of true. So we're going to return true here. But then every other possible if needs to return false. So I think the best thing to do is have a mutable variable. We don't mind that, right? We've got over ourselves sufficiently that we can have mutable variables. So we can't do this. What we can do is say, please delete this later. And similarly, if we're making the negative distance none, and also the positive distance was already none, then we want to delete this line in progress. So we get to the end of the function and we say if delete, then the line in progress becomes none. Let's write some comments because this has got complicated. So this is just increase positive distance by 1. If we hit the edge, we hit the edge, clear pos dist. If both directions are clear, remove the line. And then it's the same thing. If we hit the edge, so remove the negative distance, but if both directions are clear, remove the whole line. Let's say whole line, that'll make it easy to understand, I think. Like so. Then we remove the line at the end. That feels good. Let's try it. So yeah, boom. Things come out of you. And then when they hit the edge, they smash. Hey, that's stopping before it hits the edge. That's no good. That must be needing to be a 0 because we're checking whether we've like gone off the edge, not whether we're at the edge. Yeah, there we go. Yeah, so while that line's drawing, you can't draw another one, which is good. It's only letting me press it once the line's finished drawing. It looks a bit weird it not being there. After all, I did want it to draw the central dot. Okay, let's go back to view, because it's only the view that's wrong there. It knows that dot should be there in some very real sense. But yeah. Which direction should cover the central dot? Let's say both do. So just go. So all of that confusion wasn't even worth it. Should be start +1, I guess. So both directions are drawing that central dot. We'll double check that that works. Oh, hang on. Refresh. Okay. Now if we go over this side and do it, it's still drawn in both. Yeah, all right. So now, while a line is being drawn. So in the game, the version of this I played that was quite nice, which was the JezzBall. A thing called JezzBall, which seems to be a remake of the original arcade-ish game. The two arms had different colours. And they didn't really serve much purpose, except to show that they're separate things in some sense. Should we be allowed to move while the line is drawing? I say yes, because you can move the mouse in a mouse game. Yeah. Okay. What are we thinking? I think we're thinking the ghost is too visible. I don't want to like destroy it for people who are low vision. So maybe let's leave it as is then, because I think it's nearly visible enough for someone with low vision, or like based on the contrast guidelines that I'm used to. All right, we need a commit. What did we do? Change the addition and allowed moving around a line and then pressing space to draw it. Oh, and I've got some commented out code in there that should go. Okay, but basically allow drawing a line. Allow drawing a line when you press space. All right. How are we doing? Are we tiring? Not yet. No, we're not tired. Okay, so next thing to do is to make those lines turn into solid land when they hit the wall. And at some point when a ball hits them, they won't turn into solid land. And we'll get to that once. We haven't got any balls yet, so Let's do this last bit, and then we'll try and have some balls. Okay, so what is this? This is like bits of the world that have been filled in and are now solid. So let's say solid squares. Now we could try and make this some kind of clever thing of like a bunch of rectangles, but since it's a 25 by 25 grid, for now, let's have just all the filled in squares in a list. So it's going to be just a vec of point. And if this becomes a problem, we'll worry about it. So at the beginning, no squares have been filled in. So it's an empty vec. And if we hit the line, then that line becomes solid squares. So if we hit the line here, then the solid squares needs to be, we need to add, we can extend a vec with some points. Do we know whether we're horizontal or vertical at this point? No. So it's a little bit like drawing. This is the same logic as drawing the positive squares, which we had in the view. So let's have a quick look at how we draw them. We get a start, we get an end, and then every time round the loop. I said we didn't like doing this every time round the loop, and then I did it later, didn't I? Because I wasn't clever enough, basically, to extract this out into... It's actually pretty similar to the previous time. Like, we could just have an X and a Y and an inc X and an inc Y, couldn't we? So why don't we refactor this code to share... to move this out of the loop. We could even make pos and neg share the same code if we were really clever, but let's not do that. I think we could just... So let's refactor this code so that it's a bit nicer. And then see if we can like at least copy the structure. Probably I don't want to share the code because of view and physics code, I don't feel like they should be anywhere near each other. But let's copy the structure. So we're going to have x negative increment, x positive increment, x negative increment, y positive increment, y negative increment, like so. And if it's horizontal, x is going to be x, the positive increment is going to be, this is a horizontal line, so the positive increment is going to be 1, negative increment is going to be, I mean, should we call it -1? That'll probably help us cover it. Y is going to be the start y, and it's never going to change in either case. So that's that. And then there's something really similar. Hey, tell you what, the x and the y are both, so we don't need to, x and y are always the same. So we can just have x be the start x and y be the start y. And this gets easier because now we don't have to make x and y from this strange concoction. We're just saying the amount we increment x when you're horizontal is 1 and -1. The amount we increment y when we're horizontal is 0, and then vice versa for that. Now, if we have a positive distance, then we loop from... So we can just say, yeah, okay, well the count is just gonna, we're just gonna loop through this many times, positive distance times So zero, I guess 0 to positive distance. Loop through. And draw a square at x and y, and then increase x by the positive increment, and increase y by the positive increment, like so. And then do basically the same thing for the negative, which I don't think we want to share the code here, but like the code is simple enough now that I don't feel so bad about it. Draw the square and then add the negative increment. Right? What's it moaning about? Oh, that should be 0 to negative distance. Now x and y need to be mutable for this to work, and we need to check that I haven't completely broken everything. Why don't I have tests? Oh, and then this was some thoughts that I was having that I hadn't done yet. Whoops, no, I've done it again. I meant to compile the code. All right. I've broken it. I have broken it. I wish that I had not broken it, but I have broken it. Okay, we are in the view code. It looks like the actual code worked. So positive, negative. Oh, hold on. We've already modified x and y, dude. What should we do about that? I guess we should just do this twice. I think that'll be okay. Let's try. Oh, come on. Oh, did I refresh? Okay, what have we done wrong? Can you see it? I haven't seen it yet. So the positive x is 1 minus 1, positive negative x, positive and negative y is 1 minus 1. It's a vertical line. Set the x to the start position. If we've got a positive distance, then for a loop from 0 to positive distance, draw a square x, y, and then increase them by positive. Otherwise, draw the square x and y, increase them by negative, which of course means they're decreased, which is correct. So that looks all right. So I'm wondering whether I've messed up the calculation somehow. Because that seems okay. You know what? We don't need... We could just do x increment and y increment. All right, this is so simple. Am I over simplifying it? Because these are split up, we can just take away the x increment here and the y increment and add them above. But still, that should not work in the same way it didn't work before, and I don't know why. So let's just, yeah. So you can tell I'm hammering space, but it doesn't let me press it because actually the physics is working. It's just the rendering that is somehow not working. So I guess let's comment out the positive and try and figure out why the negative's not drawing anything, or maybe it is drawing something but not what we expect. Yeah, negative is not drawing anything that I can see. So it starts from the start position. And I mean, maybe we never get inside here. But I'd be surprised. But I guess, no, that's really the only explanation. Otherwise, how would we not? In fact, look, we can put the X and Y inside here, can't we? That'll make it much nicer. But that doesn't, I don't think that affects anything. Still not sure whether the line going vertical when I move horizontally feels good or not. We'll have to see how it feels in actual play. So I think it's time for us to start putting like a debug log in here, because if we don't get into here, that's the only explanation I can think of. Maybe I broke something up above. So let's just log something. Oh, well, we need to import console. And then, so it does get there. So it seems the error is really here. We start from the start position. Oh, look, neg_dist is a negative number. So maybe we should just, okay, go from 0 to minus neg_dist, or maybe just absolute value it. I don't know. That feels a little overdone. Hey, now the negatives are working, and I've turned off the positives, which is why the positives are not working. So we're okay. We're okay. So having negative distance be negative is interesting. It's an interesting choice. Okay, so our line draws, and at some point it disappears, which is all good. It's all good. I would kind of like, I would love to be like a cool designer who could make that look like it kind of like pulses while it's drawing. That would be so cool. We should totally do that in another video, like how to make a line pulse, but I have to figure it out first. Anyway, maybe it could just slightly change in intensity, like a different color every frame, maybe. All right, where were we? So we were making solid blocks appear, and we got to the point of, we knew where in the code we were going to do it, but we hadn't actually done it here. So what we want to do is something, you know, what I said was we're going to do something similar to the above. Now this code is getting a bit complicated, so I want to do something like call some kind of function like extend solid by, I guess it'll be like by posDist. So we need to do it before we hit the edge. Like make the line solid and clear posDist. Yeah. So extend solid by posDist. Now the choice of being positive and negative being negative might pay off, because do we have enough information to say, yeah, just extend it by posDist? I think we probably do. I'm feeling like line in progress itself should have code in it, maybe? We'll see. So let's do something similar here and tell it also extend yourself before making yourself none. We're going to make ourselves an extend solid method, which is going to, whoops, what on earth am I pressing? which is going to put solid squares in every point of a half line. So this is going to be dist is either positive or negative. And now we can get the view code. I think this should be, extend solid should be near the physics code. So about here-ish. But let's get the view code. By the way, this is a validation of why I used an I32 somewhere. Because you end up with a number that might be positive or negative, and it's going to mix in with numbers that are always positive, like positions. And it's just so much more convenient if everything is just an I32. It's a bit, in a way, it's a limitation of Rust or just of computers that mixing different number types costs you conversions. Maybe what Rust could have is a number that is backed by an I32, but you know it's always positive, and then it can still work, still like be combined with negative numbers, and then somehow guarantee it stays positive or something. Anyway, complete distractions. So where were we? We are drawing. Here's where we draw lines, and we get hold of this thing, and then we loop like this, and we're going to do something like that in our extend solid. So we get the orientations. Like so. Alright, let's pass in line in progress as well, shall we? Because we already know it's not none. So then we don't have that problem the compiler just complained about. So where it's called, we need to pass in line in progress. And still pause dist. Like so. No, neg dist. Thank you, the type system, for alerting me to my bug. It wasn't, it was alerting me to another bug, but fortunately it made me think about it now. So it's wanting us to pass in a mutable reference so that we're not mixing mutable and immutable. I think we can just go ahead and do that and it will be okay. No, hang on. All right, well, let's just pass in the orientation because that's what we... No, there's a load of stuff in here. Okay. Why is this a mutable reference? Because we might change pos dist in a minute. So we could take a mutable reference. Okay, we've got a mutable reference to pos dist only. We want to pass in like all the information about line in progress, like its start position, its orientation, and so on. But we also want the ability to modify pos dist. So what we could do is set a flag like this to say delete pos dist. And do it outside. Then we'd be able to pass in line in progress, or we could just make a copy of line in progress. If we made line in progress clonable. I think like this like in some theoretical world, this would be a performance compromise that we're making here. Now in this situation, we can just now take it in by value because we just cloned it to pass it in. In this situation, like the chances that this causes any kind of performance problem are slim to zero, like just copying a few bytes versus all the stuff a web browser's doing. So let's not worry about it. But like if I was writing production code, I would worry about it. And I'd do something different, but that would probably be a mistake, to be honest. Now, it's still sad, so we need to copy it before we do any of this. Okay, let's do that. In fact, and then we'll pass it in by reference. It saves us a copy if we do this, so why not? Pass it in by reference here, but it's our clone that we're passing in. And we'll also pass it in here. All right, so all we did there was the borrow checker was annoyed with us because we had a mutable reference because we're modifying some part of line in progress here. And then we wanted to like pass it in to someone here. And then you can't have two people able to modify things or even see an immutable reference at the same time as someone else has got a mutable reference. So it wasn't happy with us, but we just made a clone. We're passing in. So basically we copied the information about line of progress here. And what are you moaning about now? Oh. All right. Okay. I take it all back. The compiler is telling us we're doing something bad, so let's not do it. So we're just going to modify things later. So we're just going to tell it don't need the clone anymore. What we're going to do is just have an immutable reference, and where we would have cleared it, we're just going to say please clear it later. And then later we're going to be free to take it whatever mutable reference we want. And so we can delete it. Right, so let's just say here, delete neg. Now I feel like this comment is make the line solid. Better written like this. And similarly here. Just so we can see. Now, please, why are you moaning? Where is the mutable borrow used? Oh, we're still taking mutable reference here. Oh, hold on. We're modifying. Okay, so we need, instead of just knowing whether or not we delete it, we need to know what its new value is going to be. Maybe there's a better way of doing this, but new pos dist. We'll start off, we'll default it as what it was already. I think. No. We'll start it off as none. And then we just need to double check that it actually gets set everywhere. So we'll think about that in a second. In fact, maybe we could put them, maybe we could improve this by returning these from here. Yeah, if we put these inside, now we have the line in progress. So we can get hold of what's the current value of the positive distance and the negative distance. And we can say whether or not to delete. And then we're just going to get them back like this. So we're expecting this whole block to return us back a tuple, which we will just return here. You pos dist, that would have been confusing. You neg dist and delete, come back. Need a semicolon. And yeah, okay, and then we need a like the possibility that we don't get into the if let, in which case I guess we do nothing. So maybe this whole thing, yeah. No, delete needs to leak out. Delete needs to leak out and the others don't. So we'll put delete back outside because that needs to be outside of the scope of where we've got a reference, any kind of reference to. Line in progress. But if it exists, no, but then we take a mutable reference to it here. Oh, I'm so wondering what the right design for this is. Let's just pause slightly and think it through. Well, let's see if we can get rid of this horrific signal as well. So we're not going to need. We're going to just come into the if let and do something, and we can avoid the negative. Avoid the mutable reference to line in progress while we're doing other stuff, like using line in progress here. We set delete pos. Yeah. All right, we'll go back to booleans. Yeah. So we're just going to process these at the end of this little block while we've still got a mutable reference to line in progress. Is that right? I'm a bit worried that this is... We're back to our problem. Yeah, the problem is that we've got this mutable reference to line in progress. And now we're trying to pass it to someone else. Let's actually read the full error message so we've got to make sure we know what we're doing. I mean, there's a load of other pain here because I pasted some terrible thing in here. So let's just make that noise go away. And think a little bit more. And we must be getting towards the end of this video, I'm afraid. I hope to have a working game, but I think probably we're not going to, because instead we're going to fight some lifetimes, but that's cool. Alright, so pos dist is not mutable reference, but also we can't call methods on ourselves when we also hold a mutable reference to something. So I think what we need to do is decide either we're going to... I mean, this would probably get easier if we didn't break it into a separate function. I think that's the source of all of our pain, isn't it? What if we write this and try and do it without a separate function? And then curse Rust for making us do things the bad way. And then you can leave a comment telling me how I could have easily done it with a separate function. So this is just going to be pos dist. No. Yeah, this doesn't quite make sense, because we've got a reference to pos dist and we're trying to set line in progress dot pos dist to none, right? That doesn't feel like that should be allowed anyway, because we've got a reference to pos dist, but it seems like I am allowed to do that. So let's carry this through and see where we get to. Maybe because we've stopped using that reference, we don't use it any later, do we? Yeah, that's probably it. Okay, so we need to make it solid. So we're just going to start off with X inc, Y inc being the orientation, giving us either a 1 or a 0 for each of them. And then I think we're just going to kind of loop, except what we're actually doing is, now this is where it's going to go wrong, because we want to modify solid squares, but we've already got a mutable reference to self. So is that going to be a mutable reference to something in self? Is that going to be okay? I don't know. So for a second, just to check that any of this makes any sense, let us make ourselves an iterator of just some points that are just random. And we need to take a mutable reference. Also here. Oh, I feel like I'm just waiting for the borrow checker to come and smack me. No? Still okay. Fine. So we can, it looks like we can change self, even though we've got a mutable reference to something in self, because they're both about self being mutable, so it's fine. The problem was about calling a method. Maybe if I'd made self on that method mutable, we'd avoided this problem, but now I'm scared. So I don't want you to watch me just flail around and not know what I'm doing for hours at a time. It just hurts my ego. All right, so X and Y are going to be the start. X and Y. And we're going to do some kind of loop. Yeah, up to the positive distance, isn't it? For underscore in 0 to positive distance. So it would be nice to have an iterator. I don't know how to do this. Fine. Let's not do that. There's probably a nice iterator way to do it. Is it really nice, or is it just harder to understand? So we can just push things into solid squares, which are, maybe it should be a set actually, solid squares, but anyway. What we're going to push in is a point of X, Y, and then I guess we need to, I've kind of lost the plot, but I guess we need to then increment X by inc and increment Y by Y, inc. And they need to be mutable for that to work. And that seems right. And can I extract that into a function? Yeah, it took a mutable reference to self when I extracted into a function, and then it broke. So thanks LSP, but no thanks. How are we doing? Something like that? Have I lost? No, all right. And then we're going to do something really similar for negative. And I'm just going to paste it in at this point. And then make it be equivalent for negative distance. And because we're going in the negative direction, we take one off instead of adding one on. Now these solid squares have been added in. I believe, and again, some tests would really help us know whether we had or not, that we've now added the solid squares for all the points of this line. So when we hit the edge, the line becomes solid. Now we need to render that if we're going to have any idea whether it works. So let's render the solid squares by setting our color to the solid square color. And then looping through, they'll just loop through all the solid squares. This could be terrible, especially because there could be repeats in here because we haven't made it a set or anything like that. But I mean, I bet again, performance. I mean, potentially there is a performance implication to drawing more stuff than you need to on a canvas. But again, this canvas is 151 by 151, so it's very hard to make performance struggle in a modern. Hey, that's not quite right, is it? You shouldn't just stop when you hit the edge. You should stop when you hit anything else. Anyway, this looks kind of fun. We got things turning into solid squares. The solid squares seem to be rendering on top of our line because I rendered them after, which doesn't seem right at all. So solid squares should be rendering. They should definitely be rendering before the positional dot. Where does the ghost live in this order? Maybe the ghost shouldn't be drawn until the line's finished. Let's get rid of that warning. Whoops, what happened? Sorry for the flash of white. Okay, so it looks like at least our dot is now visible on top of the solid squares. Okay. So we're going to leave it there. Hopefully that we've got to the point where we could probably write a game if we did another video similar length, maybe, I don't know. But yeah, so what's needed next? So what oh look, the solid squares go past the edge. That doesn't seem right. All right. Anyway, they should stop at they shouldn't like cover up the blue. They should kind of be the same color as the blue because in a way they're just more edge that you've created. But anyway, yeah, so if you've never played this game, you probably have no idea what I'm going on about. But the idea is that balls bounce around and we build walls that trap them in. And when we've built a wall, so all the balls, let's just start again. If we build a wall here and all the balls are stuck in the top, this bottom bit will all get filled in and we get points. And then when we have enough points, because we've trapped the balls into a small area, then we can proceed to the next level, essentially. So what's needed to make this into a game, apart from things like multiple levels, keeping score, high score tables, all the usual guff, is we need balls to bounce around. We need to fill in bits of solid space if they're if they've created an area with no balls in. So we need to like detect whether the balls are in a particular space or not. And we need, when a ball comes along and the line is still being drawn and it hits that line, we need that line to get cancelled. And for you to lose a life. I was almost wondering whether it's like if you get cancelled, you immediately die, like no lives, as a possible. I guess that's only one game mode rather than it being like mandating. That seems a bit harsh since that's not the way the old game plays, which is good because I've implemented a load of code that kind of assumes that it matters that the two halves are separate and they solidify at different times. So yeah, other than fixing that bug where we're, I guess we're just rendering solid blocks that we shouldn't be. Although we shouldn't really be creating those solid blocks either. Yeah. In fact, can we fix that? Can we just not make those solid blocks by just doing a -1 somewhere? Where was it? Solid squares. Yeah, so what if we went up to, how's this -1 here, and same for negative. Well, I guess it would be negative blah -1. So confusing. Whoops. Okay, that's better. We fixed it. Okay, I'm going to do a commit so Jez doesn't kill me. And next time we work on this, which may or may not be next time, let's make a game that's playable. I feel like it's kind of fun. It feels nice to control. Hope you enjoyed the Rusty game stuff. It feels typical of a game that you've got a game loop and you do stuff every time step, and that stuff is basically physics and rendering. So hopefully it's sort of slightly instructive of how games work. Hope you enjoyed. Leave me a comment, especially if it's nice, and see you next time.